You know, this is a 400 horsepower Mustang. It's a good idea to run premium gas in these cars, and it's even good on emissions, and that's what today's show is all about. Gasoline and emissions. I'll meet you back at Tech Garage. Welcome to Tech Garage, presented by Advanced Auto Parts. It's amazing that the manufacturer can put 400 horsepower into these vehicles and yet reduce emissions. And that's what today's all about. What's going in the car and what's coming out. And a little bit later, we'll show you some diagnostics on an O2 sensor, and that's one of the big heavy hitters when it comes to fuel delivery. But it all starts out with fuel. You know, when we talk about fuel, you probably heard the terms volatility and octane. Now, volatility is how easily it evaporates. If you have high volatility, it's going to evaporate real quickly. We got an EVAP system we'll look at later that'll catch some of those fumes. If you have low volatility, well, then it may not evaporate at all, maybe some hard starting concerns. Another term is octane. Octane is the ability to reduce spark knock. And you can see I have a piston right here. And what happens is that piston goes up and down in the cylinder. And when it goes up and down in the cylinder, if the fuel's not burning correctly, that piston's going to go from side to side and knock on the cylinder wall. Well, our cars have a knock sensor, and that knock sensor sits right here in the coolant jacket. It's a little piezoelectric generator, and what happens with that knock sensor is it senses the vibrations in the coolant. And when it does that, it reduces the timing. It takes it back from advanced timing to reduce. And I could show you an example. If we fire up our board here, what's going on is the fuel injectors are pulsing. And if I give it some gas, the timing moves up. So the timing's continuously creeping up to that optimal timing, and then it walks back when it sees that knock. Creeps up and walks back. Well, if you're putting in some low octane fuel trying to save a little money, what's happening is the car may be knocking, the piston's knocking. So the knock sensor and the timing keeps reducing it back, and if you drive like me, you're giving it more gas to go faster. So that high octane's probably a good idea. Now we gotta atomize all that fuel. In order to atomize all that fuel, the fuel pump develops a pressure, and when it develops a pressure, it sends it through those injectors and it sprays it in a fine mist. And we'll see a little bit later that that mist has to go into that cylinder and it has to evaporate, and then it burns and pushes on the bottom of that piston. This one here develops about 40 to 50 psi. Now remember, some cars may have direct injection. Direct injection has a direct injector pump, and this guy can develop up to about 3,000 psi. Whew, that's a lot, and we're putting it right into the cylinder. So now, not only are we shoving it into the cylinder, we're boosting the pressure, we're putting it right in the top of the piston. Diesel's done it for years, made spontaneous combustion, but ours is gonna go in there, create the spark, and then get a perfect burn as it goes down. But you know, if you end up with some fuel like this right here, it starts to get dirty and varnished. We got the solution. We got an expert here from STP, and we'll talk to him next. Well, we learned a little bit about fuel, but we're going to learn a bunch more. And how are we going to do that? Well, I brought in an expert. Bobby Elks is here from STP. Bobby, you know, I go into the parts store and there's rows and rows of products. I mean, fuel injector cleaners, fuel stabilizers, fuel tank cleaners. I mean, there's one after another. How do I know what to choose? What's going to help my car? What's going to prolong my engine? What's going to clean my injectors? Help us out. Shed a little light on these products.
Yeah, walking into that store, there's a huge wall of products, and it's very confusing to the customers. But we got to understand what they're looking for. Are they looking to clean their engine, or are they looking to prevent deposits from forming? So that's what we got to start with. Every morning when you wake up, you go and you brush your teeth right away, right?
I sure do.
Absolutely. You want to have that fresh breath. But every 6 months, you're supposed to go to the dentist, right?
Yep.
What does the dentist do? The dentist cleans your teeth to get rid of the plaque, the tartar, all the buildup, right? So that's what you want to do if you've never used a fuel treatment before. The deposits start building, and you got to take care of them. You got to clean them before you do anything else. And here's where we recommend one of our fuel system treatments right there. What that's going to do is it's going to remove any of the deposits that built up on the combustion chambers, the intake valves, and the fuel injectors. It's going to get rid of them. What it's also going to do is it's going to help restore the power to that vehicle, and it's going to save you money because you're going to get better spray patterns and you're going to get better gas mileage.
These spray patterns you're looking at here is a good spray pattern. This is perfect. This is called offset. It's not spraying down on the cylinder. It's probably not going to atomize. Neither is this one. This is probably clogged, and this one's dripping, so you're not going to get any atomization whatsoever. That's not even going to burn. Bobby, out of the two patterns, which one would you want to have?
Definitely the one on the left. As you can see, it's a steady flow, but this one right here, that one's split. That means something is clogged up in the top of that fuel injector, so you're not getting the proper spray pattern.
And how often should I use this product?
With the fuel system treatments, we're going to recommend using these every 3,000 miles or every oil change. Then after you do that, what you're going to want to do is every tank after that, you're going to want to put in a maintenance, like you would brush your teeth every morning after the dentist. That's where these bottles come into play right here.
Now I have a fuel pump here, and this fuel pump sits in the tank with all that gasoline. And you can see this one, it's all deteriorated. The hose is ruptured here. I mean, this thing's been in some rough fuel. I know it's not going to fix this, but will these products help prevent issues like that, corrosion and contamination?
Yes, they'll absolutely prevent corrosion. That's what we're here to do. These 4 products will work great, but coming soon, you're going to see our new Ultra 5-in-1. That'll be hitting the shelves very soon. Look for that. That will encompass all the products right here. Recommend using that every 3,000 miles or every oil change. Then maintain it with one of these bottles right here, and you're good to go.
Now these are all great products, but we have to get it into the engine, and that's the job of the intake manifold. And we'll look at that as soon as we come back with more Tech Garage presented by Advance Auto Parts.
This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by STP, helping cars run better longer since 1954. ARP, the world leader in fastener technology. Locar, quality plain and simple. And by Advance Auto Parts, let's get you back to the garage.
Welcome back to Tech Garage. Well, we're good with fuel, and now we need to get that air and fuel into the engine, and that's the job of the intake manifold. Now, I have several intake manifolds here to show you, but before I do, you know we have to get 9,000 gallons of air into that engine with 1 gallon of fuel. That makes a perfect air-fuel ratio of 14.7 parts of air to 1 part of fuel. That's called a stoichiometric number, and a little later we'll look at an O2 sensor, and just keep in mind, if we start getting more air, it may be 16 parts to 1 part. That's a lean condition. But if we go down to 10 parts of air and 1 part of fuel, that's a rich condition. But the intake manifold all started right here with a wet intake. Well, a wet intake, we're familiar with carburation. Carburation takes the fuel and air, sends it through the air filter, through these runners, and down into the engine. Now the air filter, important piece of the puzzle. It's filtering any sand or debris. Sand is sand. It gets in the engine, just like sandpaper, it's going to score up the cylinders, so make sure your air filter is in good shape. Then we went to injection down into the engine, and we went to these air plenums. Now the air plenums, the throttle body would bolt right here, and the air would run over. And I got a cool one here to show you because it has a biflap in it. 2 different types of runners going into the intake manifold. There's long runners right here. Now this is good for low RPMs, and then the high RPMs, we use the short runners. And I can even show it to you in action. If I flip it over here, and I got our smoke machine, what I'm going to do is I'm going to develop some smoke, put it into this intake manifold, and when I put it into the intake manifold, you'll be able to see where it starts coming out here. Now, I'll simulate the computer. I'll actually come over here, plug a vacuum pump in, and I can open up the runners, and you can see the smoke bellow out of all of them. So if we get high RPMs and we need more air, this plenum has the ability to do that. We can also use this smoke machine to check for intake manifold leaks, and we can do that right over here on our Mustang. 2 ways we check for intake manifold leaks. Well, you can get some carburetor cleaner, spray it around and check for intake leaks. This is an artificial fuel. So what's going to happen here is the car's going to idle up a little bit, and at least you got the general idea, but you really need to be careful with this because it's flammable. If you got any open spark plug wires, it'll catch on fire. We'll just use our smoke machine. I can come right here, disconnect one of the hoses going into the intake manifold, and then what I'll do is I'll inject smoke into the system. Now, while I fill the system with smoke, if there was any leaks, what would happen is you would actually see the smoke. The smoke comes bellowing out here, and then you found your vacuum leak. You just need to go and make the repair and make sure everything's in order. We have to get that perfect mixture, that 14.7 to 1, and that's the job of the O2 sensor. It's going to mix the fuel delivery in there perfect to give us that 14.7 to 1, and we'll look at it next. The oxygen sensor does exactly what it says. It senses oxygen, not fuel. And it's located in the exhaust stream. And what it does is it reports to the computer what's going on down in the exhaust stream. How does it work? Well, there's 28% oxygen in the outside atmosphere, and if there's 28% oxygen in the tailpipe, that means there's no pressure difference. It's not going to create a lot of voltage. It may be 100 to 200 millivolts, but if there's a lot of fuel in the exhaust and there's no oxygen, well, see, that makes a big pressure difference, and that pressure difference creates a voltage. So after 450 millivolts or higher, that's a rich condition. Remember, command corrects condition. So on these computer command cars, what happens is, if the fuel is real rich down there, he's going to tell the computer, hey, take fuel away. If the fuel's real lean down there, he'll tell the computer, add fuel. Now I have a couple right over here to show you in the exhaust stream, and there's a few important things I need to point out. First of all, it's located right in the exhaust stream, and this is the catalytic converter, and we'll look at what the catalytic converter does a little bit later. But for now, there's a pre-oxygen sensor before the catalytic converter, and there's a post-oxygen sensor after the catalytic converter. Now, its job is to take care of all those HCs, carbon monoxide, everything that's coming out of the engine. So when we come into the catalytic converter, everything's going to be rich, there's going to be a lot of fuel. So this sensor right here is going to go rich, lean, very active. He's going to tell the computer how to mix it. Well, on the other side, if he's doing his job, the catalytic converter is doing his job, what's going to happen is this one's going to be kind of flatline. Should just come out with a nice mixture of fuel, air, gas, take care of all that out the pipe. Two things I want to show you. First of all, the connector lengths. You head down to advanced to get an oxygen sensor, you need to know what's going on. This could be bank 1 or bank 2. You also have sensor 1 and sensor 2. So if this is bank 1, this is going to be bank 1, sensor 1, bank 1, sensor 2. You can see the connectors are actually different here. The lengths of wires may be different, so you have to know which one you're dealing with. When you scan it, it may come up with an oxygen sensor code, and that might not be the problem. So we need to look at some diagnostics, and we'll do that when we return with more Tech Garage presented by Advance Auto Parts.
What system problem would cause air-fuel ratio to be 10 to 1? A, vacuum leak, B, clogged fuel filter, C, injector not pulsing, or D, stuck open injector. The correct answer is D. A fuel ratio of 10 parts of air to 1 part of fuel indicates a rich mixture. Too much fuel, not enough air. A stuck open injector would cause a rich fuel mixture.
Welcome back to Tech Garage presented by Advance Auto Parts. Well, we got our scan tool hooked up and we can look at the O2 sensor in action. We fired up our board, just like your car. This O2 sensor is reporting to this computer and we can see it happen. What's going on here is it's actually crossing that threshold. Remember earlier? Rich, lean. Well, it's going as high as 975 millivolts and it's dropping as low as about 115 millivolts. Down here, it's lean. Up here, it's rich, but the key is it's switching rich, lean, and that's what you want with your car. You want it to switch from that rich to the lean to the rich to the lean. The quicker it does that, the better fuel you're gonna get, the better mixture you're gonna get. You're gonna get to that 14.7 to 1 number. That would be right along the middle. And I'll go over here and I'll nail it for you, just like you would, and you can see it went rich, and then the computer says, hey, take that fuel away, we're going lean. And then he starts getting it back under control and he meters that fuel. So that's a really good look at that system. Now I come over here, there's some diagnostics that you want to make. We pulled it up on our MotoLogic. Professional techs use this MotoLogic and it actually tells you a little bit, exactly what we just looked at, from 200 millivolts to 800 millivolts. Then it says some contamination here, and this is important because this is when it starts getting sluggish or it starts getting slow. You can see here, silicone contamination, fuel contamination, oil consumption, and coolant consumption. If we start sending stuff down that exhaust stream, it contaminates that. RTV, room temperature vulcanizer. If it's not sensor safe, it'll contaminate it. Or you pull the intake manifold off and some coolant dumps down there, well, that also can poison it. But you can pull out your oxygen sensor. You just have to go down to the exhaust stream and get a tool like this. What it does, it slips over the wires. And when it slips over the wires, it allows you to get to the threads down here in the actual nut and take it off. Or they make a tool just like this one that goes over there, gets on there. You can pull it out, check it, visually look at it, make sure it's not contaminated. If it looks bad, go down to the auto parts store, put a new one in, and you'll get good fuel economy. Now we're good with what's going into the car. Let's take a look at what's going out, and we'll talk about some emissions. There's a few gases we can look at. The first one's HC. That's hydrocarbons. That's just raw fuel that's getting through and coming out. There's CO, carbon monoxide. Now, carbon monoxide is a byproduct of combustion. If anything fires or the cylinder fires, you're going to have some carbon monoxide. And then there's NOx, oxides and nitrogen. When an engine starts getting hot, it produces some oxides and nitrogen. And of course, there's oxygen coming out and carbon dioxide. But what we can do is we can fire up our scan tool, we can put it in there and take an actual 5-gas analyzation, and that'll tell us what's going on in the exhaust and what kind of gas is coming out. So I'm going to go ahead and fire it up. We're ready to install it. Hit enter. Now our gases are up there, but we go ahead and crank the car. We're going to need to have the gases back here, and then I'll stick this in the actual tailpipe. Now we'll let it go ahead and catch up. It starts reading. You can see on the top of the screen here, that's our CO2, our carbon dioxide. A good running car produces about 13% to 16% carbon dioxide. And then there's COs, which is carbon monoxide. This one's producing about 1.28. HCs are hydrocarbon. Hydrocarbons are that raw fuel. This is about 48, 50s, fluctuating a little bit, parts per million. You don't want anything in the 500 range. That would be a lot of fuel coming out of the tailpipe. And then you can see the O2 number there, and then there's the NOx, the oxides and nitrogen. Now, when a car gets hot, oxides and nitrogen are going to go up, and they're actually opposite. COs and HCs will be here, NOx will be here. If I actually take the HCs and the COs and I start reducing them, well, the engine's going to get hotter and you're going to get NOx. So it's a fine balance between the two. And then right here on that last thing, you can see that average fuel ratio. Well, this car is at 14.85. Man, we said 14.7 was perfect. This thing's right on the money. These are good readings, and this will tell you exactly what's going on with that exhaust system. You know, we need to come back after break with an email question of the week.
What would indicate high oxides of nitrogen and low hydrocarbons and low carbon monoxide readings on a 5-gas analyzer? A, overheating engine, B, misfiring engine, C, leaking injectors, or D, low engine temperatures? The correct answer is A. Oxides of nitrogen are produced when combustion temperatures are too high. Vacuum leaks, lean fuel mixtures, and an overheating engine will raise combustion temperatures, thus increasing oxides of nitrogen. This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by STP, helping cars run better longer since 1954. Stage 8, the world's best locking fastener. Steel Rubber, quality crafted rubber parts and weather stripping. And by Advance Auto Parts, let's get you back to the garage. And now the email question of the week, presented by Advance Auto Parts.
John, I've got an email question here from Curtis in Columbus, Ohio. Curtis has a vehicle that only has 72,000 miles on it, but in the last few months he's noticed that it's lacking power. He did a tune-up with a new air filter, a new fuel filter, and even replaced the plugs and wires and tried premium gas. Still not running properly. What else can Curtis check?
Brian, Curtis could have a clogged catalytic converter. That could cause bad fuel mileage, and if it's severe enough, it could cause engine seals to start to blow because the exhaust backs up pressure into the engine. And you can see the catalytic converter right here on the Mustang. It comes down, and here's the post-oxygen sensor. But I have one on a table right here so we can perform some diagnostics. Now, the catalytic converter takes the HCs, the COs, and the NOx in on this side, and through a process of chemical transformations with rhodium, palladium, and platinum, out the other side is going to come water, H2O, and CO2, carbon dioxide, if the car's running properly. You can come over with a pyrometer or check the temperature on the inlet and the outlet. The outlet should be 10 degrees hotter than the inlet because it's an oxygen storage container. It's like blowing air on a fire. It should get hot as it comes out if it's burning those gases. You can take a rubber mallet and hit it, see if it's rattling, if you have any thermal breakdown of the material inside. You can also hook up a back pressure gauge. Take the oxygen sensor out, go in line, look at about idle, you should have about 1.5 inches of pressure. At 3,000 RPMs, you should have about 3 PSI of pressure. That should take care of Curtis's problem if it's a catalytic converter, but there's one more pesky emission systems I want to look at, and that's the EVAP. If you've been messing with cars long enough, you've seen the infamous check engine light with a code P0442. Well, that's an evaporative emissions leak. And it's real common because it has a hard job to do. The evaporative emission systems catches the fumes when the car's not running or when it's running and stores them in a charcoal container right here. Then at a predetermined time with a series of EVAP solenoids and purge solenoids, it purges and it lets it go back into the engine. There's also a pressure on the tank so it knows if anything's bleeding down. And if you suspect you have a leak, you can just come over, take the cap off. I went ahead and removed the Schrader valve right here. So I got it out of there, and then I can put the smoke machine on it. When I put the smoke machine on it, I'm gonna put smoke into the system. And as I smoke the system, just walk around your car. Look at the solenoid, look at that. Look at the container. Look at all the components that are involved with the EVAP system. And then it'll start filling up with smoke, and you can see it's bellowing out the cap. Now you can perform these tests right on your car. Just find an evaporative line, pull it off, or find the cap, fill it up with smoke, and look around your system. You know, it may be as simple as a fuel cap leaking. Now throughout this program, we looked at the fuel coming in and the exhaust coming out. So get out to your garage and fine-tune these systems to stretch your fuel dollars. Like always, from our garage to your garage, thanks for watching Tech Garage, presented by Advance Auto Parts.